Hi, welcome to day 2 of coding every day. Anyway, and this question is of medium solution, and trust me, I never solved this before, and I don't know the solution as well. So let's see how much time it's going to take. He's saying we are given a nums array containing only positive integers. All right, and they're saying a subarray is set complete if the following conditions are satisfied, and the condition is that the number of distinct elements in the subarray is equal to the number of distinct elements in the whole array. All right, subarray is basically like we have this nums array, right? So 1 3 1 3 1 1 3 2 1 3 3 1 2 3 1, all of these are subarrays. They have to be like consecutive. It should be like a consecutive length. You can't take 1 1 2, you can't skip any element in between. You have to take in a continuous manner. So you can take 1 3 1 3 1 1 3 2 like that. So a subarray is contiguous non-empty part of an array, which is, and we need to return the number of complete subarrays. All right, I know that such solutions we have to solve using a sliding window pattern in order to be efficient, because they are saying the num slip in is 1000, right? So if you want to write a brute force solution, and since this is a medium difficulty, it's not going to work for us. So brute force solution would be like first I will check the number of distinct elements in the whole array, and then for each subarray, so I will just check 1 3 1 3 1 1 3 1 2, and then 3 1 3 1 2, like that. That will give me the solution, but it's not going to pass all the test cases, as the nums array is actually kind of big. If you take it like it will be like 1000 square, right? No, 1000 to the power of n, it's not 1000 square. So for this we use something, a methods called as a sliding window. And sliding window is basically like, we'll start with a window size of 1, and then we will check if this particular window has met the conditions that we are looking for. In this case, if the is it complete or not. If it is complete, then no, if it is not complete, I will tell you this condition first. If it is not complete, we will include the next element, and then we'll include the next element until this sliding window is not complete. Until this sliding window is complete, we will keep doing this. So once we are in a position where a particular window is complete, then what we will do is we will start removing the left elements, because maybe we achieved this complete condition without including this first element, right? Then we should also take that into perspective. So for example, here the number of distinct elements in this array is what is it? It is 1 3 1 is already taken, so it is 1 3 and 2. So if we take one subarray of 1, it is not complete. If we take 1 3, then 2 is not present, right? So we can't consider this. 1 3 1 and 2 is not present, so we can't consider this window. And if we consider 1 3 1 2, in this case we have met the condition. All the distinct elements is 1 3 and 2, so we have a complete subarray here. So now what we'll do is we will start removing the elements on the leftmost of the window. So because if we take out 1, right, we still have a subarray which is a complete one. So here this 1 is not adding any value to the previous solution, so we need to check all those cases as well. So once it is done, we'll check 3 1 2. If until it is incomplete again. So 3 1 2, is it complete? Yes, right, so it is complete. So we'll remove 3, and then we'll check 1 2, it is not complete. So now again what we have to do is we need to move the right limit of the window. So we will include 2 again now, and it is not complete, right? So once it is done, we are good to close, because by removing the left ones it's not going to make sense. So we have to loop in such a way that the right index is uh, greater than or equals to length of the given array. So maybe that can give us the solution here. So anyway, first thing we have to check the number of distinct elements in the number of distinct elements in this in the nums array. So for that I can use an hash map. So let's do make of map of int, and we'll just say bool, because if it is present or not, or otherwise we'll just int. So I'll just bool only if it is present or not. So and I'll also rename this map, so is present. So once that is done, we'll loop through the elements, element in range of nums. So we will check if so we'll check if I mean, we don't have to check actually, we'll just we can just keep is present at element is equals to true. We'll just keep it as true. So once that is done, number of distinct count is equals to length of that unique elements, right? That would be the number of distinct elements in the given array. Now that once that is done, we have to start the window, right? So left one is left and right will start to be 0 and 0 and 0. Once that is done, we will keep incrementing for right is less than length of nums. For right is less than length of nums until we are within the limit. We will check. So 1 second. Oh, I think here so what I'm thinking is so once we move right to the right, we will have one, we have to remove one, and if we have to remove one, how can we say like there is another one in the map that we are looking? Maybe I can keep the count of elements. So if I have like on the left limit of the window, if I have one, I can decrease the value. If I'm moving, then I can decrease the value of one from the map, but I need to check that okay, I can still take if it is becoming 0, right? I will just remove it altogether, then yeah, I think that will work. So yeah, anyway, so if I'm at right and we are starting at right, so current map or cur map is equals to make of map of int and int. We are going to have int here because we need to keep the frequency of the elements. So we will say cur at map at right is going to increase, is going to it is going to increase, right? So now if while length of this current map is equals to the distinct count until that is true, we will keep moving the right one, and we want a solution, right? We want a final solution here. So output, let's say 0. So until this is true, then we have a subarray, so we will keep increasing it until this is true. Once we calculated for that subarray, we want to move the left index, right? So before that I need to remove that left one from the current map. So we say current map at left minus minus, and if current map at left is equals to 0 or let's just say like value, because value and okay, if okay, then if okay and val is equals to 0, if it is present as well as that value is equals to 0, then we will just remove the left one from that current map at left. Once that is done, we will move the left side of this window. Once that is done, we want to move the right one. I think this is all. This should be the solution. Let's check. Return out. Honestly, I don't know if it is going to work or not, but let's check. It should not work because okay, it's saying there are not enough arguments for delete, expected to found one. Okay, I think we have to say like from current map you please delete current map whatever the element at left is. I don't want to. No, actually I should remove the this nums, whatever nums at left is. I have to remove that, not so even here it should not be, it should be nums at left, and here it should be, we are not concerned about the index, we are concerned about the element at that index, right? So this should be the solution. Element equals to length. Okay, let's see. Index out of range with length 5. What does it mean? Saying length 5. While left is less than or equals to right. I don't know. The current map is equals to distinct count. Okay, 1 second. So left is becoming out of range. Current map at at left. Current map at left. Okay, and val is equals to 0. Current map at left. If it is equals to 0, then only deleting. I think here okay. I think it is taking a copy of that current map. So if length of current map is not equals to distinct count, then break. So yeah, now it should not be taking the, if it is not taking for, if it is not, then we are not concerned about this loop at all. So let's see. Next, it is still happening. Is not equals to distinct count, then break. Index out of range with length 5. Is not equal to distinct count. I honestly don't know why it's not working, because why is it left is becoming greater? Why is it keep on, why did it keep on going to the right? For left less than right, let's just do this once. One and yeah, 1 2 1 2 3 4 1 2. This is one, it's true, so we'll remove this. Okay, I think we have a problem with our logic, because we can't move the left index. Because one, this is true. I don't want to move the left one yet, because 1 2 1 2 3 1 2 3 4. Once that is done, 1 2 3 4 5 6 and 7. Oh shit, I think we have a problem with our solution, because if we have like duplicates, right, then every element is going to form a unique one. So how can we tackle that? 1 2 1 2 3 1 2 3 4. All right, 1 2 1 2 3. So that should be like this case as well. I don't know, honestly. Do you think I should see the solution? Because I don't know how much time it has been recording. Let's see. Yeah, it's been already 20 minutes. I think for medium 20 minutes is enough, and I'm still not able to come up with a solution, right? Like not at least a base for this. So think I want to see the solution. Hmm, I don't know, I'll just see the solution. Or let's see the hint first. Say k is the number of distinct elements. Our goal is to find the number of subarrays with k distinct elements. I mean, that is okay, I know. That is just a rephrasing of the condition. Small, you can check every subarray. What the fuck? He's expecting us to check every subarray. Seriously. Seriously. uh, I don't know. Let's see. Then he's asking us to check every subarray, right? So we'll have this current map. Maybe probably since we are going to check this one for every case, let's keep it here. So for I less than length of nums I plus plus num set I num set I. Now for j I want to start from I plus 1, j less than length of nums j plus plus. Now I will include this current map at num set j. And instead of increasing here, let's start from I only, because I want to I don't want to write a repeat logic. So let's see, I will increase this, and if length of current map is equals to distinct count, then out I will increase the out. Yeah, isn't this the solution? Let's see. And this will be an error because I'm not using them, right? So let's see. Yeah, let's try submitting. Yeah, anyway. I did not expect this to work, because considering the array size, I was hoping that it might what do you say, it might time limit exceed. But yeah, they is saying this is not I'm sorry for misleading, but from what I read before, I thought this might time limit exceed. Let's see if there are like any better solutions than this one. See, there is a O of n sliding window. Let's check that. I need to find the number of the number of distinct nodes. I need to 1 3 1 3 subarray with these 3 distinct elements. And therefore, using 2 pointers. If I encounter the number of distinct and the nums by using unordered begin size. This was the unordered set stored unique elements of the size. And so basically, this unordered set is basically, it will only store the distinct elements in C++, and it is just checking from beginning to end whatever elements were there, they will be added into this set, and is taking the size of it. That will give us the distinct count. And this works as unordered stores unique elements only. So the size of a set containing all elements of nums is the number of distinct elements in nums. When we then use 2 pointers and j to traverse through nums and count the number of to the number of distinct elements is separated by maintaining temporary another set or map while looping. Lastly, we return the number of square with k distinct. So he's saying brute force. This is exactly what we did. So not very useful. Like we firstly calculate the distinct, then traverse through nums and keep inserting elements into our map. Then traverse through nums into our map. Reaches size k or the denominator map as are the same, and then we simply count nums dot size minus 1. Simply count nums dot size minus 1. Our result count as from index I till the end of the array. All possible subarrays will be. Acha, I think the previous solution that we did can be modified a bit to make it work, because he's saying nums dot size into a result. So here to 1 2 3 1 2 3 1 2 3. Okay. Five 1 1 3 1. 3 1 1 5 have 3 distinct. To 1. So 5 1 1 3 1 5 1 1 3 5 1 1 3 1 5 1 1 5 1 1 3 1 1 5 1 3 1 have 3 distinct. From left on to reduce as of pyramid, maintain the count of number of distincts as 3. It's a bit complicated, to be honest. For nums k equals 3, initialize left as result 0 mpp, iterate from I from 0 to 4. Okay. 0, add 1 size 1, no full window. I equals to 1, add 3, no size is no full window. I equals to size no full window. I equals to 3, add size 3 is equals to k. Okay, while size equals to k, result plus equals to 5 minus 3 is equals to 2. One second. What do we need to add here? Result plus equals to 5 minus 3 is equals to 2. Why did he do that? Result is equals to 2. Size minus That index is adding, it seems. 2 rest is equals to 2. Remove num set left is equals to 1. So left is equals to 1. Uh, Still full. Rest plus equals to 2. 5 minus 3. That index 2. Minus 3 is 2. Minus 3 nums minus that. 1, 2, 3. Adding those 1, 2, 3, 1, 2, 3, 4. Sorry. And still plus is equals to 2. So 1. So this is the only solution that we have to uh, change, while that size is equals to k, we are increasing size minus I. Anyway, that's the solution. It's okay. We're not able to come up with the best one, but still it's alright, I guess. So anyway, thanks for watching. Do you want me to try that before solution, try to modify that? Let's see if I still have it or not. Yeah, I think I still have it. I mean, so instead of doing out place, I need to do what do I need to do? Out place is equals to length of nums minus right. Yes, I don't know why are you going to why length of current map is being changed here, right? For length of current map is equals to distinct count. Is not equals to distinct count, then take still don't understand why. Anyway, I don't want to spend more time on this, but yeah, I think I understood the crux of this one. Thanks for watching, guys. Bye.